Hey, mister. So, what's your name and who's that with you?
My name is Dennis Braxton, and this is Alexander Lee Braxton. This is my son.
Oh, you're cute. So, where are we?
We are in my little R&D shop, which is me and dear associate of mine named Vern, who we work together at times. And this is my little corner of the world where I work on my generators.
Alright, and is this your generator that I'm looking at here?
Yeah, this is actually a prototype of a generator which I have designed and constructed.
So, this is the generator itself. This powers something.
Yeah, this is a prototype design or breadboard design generator that uses superconductivity, which is superconductive materials, which creates current that can run a home.
Okay, I see a lot of little boxes and stuff wired together. What are these boxes?
Well, this is a DC power unit. Right here are basic thermocouple units, which means they control temperature, feedback temperature. These are other power supplies. This is a coolant regulator unit, a high voltage unit that we use in our process of making sure that our materials stay superconductive. And then also you get an output reading of voltage that we have. This is pressure gauge. It shows how much pressure is in the system. And it's a vacuum gauge. And also we have a fluke meter that shows what our voltages are and what our current is going to when we start to increase the current inside our machine.
I see a real big red button there.
Yeah, that's the stop button.
Haha.
So if the current gets too high, we're able to stop the voltage and try to maintain the current.
So, what are these two little boxes over here?
These are Tesla, high voltage Tesla coil boxes, which are used for creating a high electrical charge.
And these all are needed for the generator.
These units help turn our material, which we use in the generator, superconductive, and then we're able to use. Yeah. This is my time now. We use those superconductive material into the generator by storing current.
I see that you have liquid nitrogen over here. Is that like, you need that?
Yes, liquid nitrogen is one of the tools that we use while we're turning our material turning it into a superconductive material.
Right, and I see this cute little jar here with stuff in it. What is this?
That's actually the generator. All this supports that unit. So what happens is inside of that unit, liquid nitrogen is stored. The material turns superconductive, and then the power starts to build up inside of that unit.
Wow. And
Then the power in that unit is diverted out of that unit into your home.
So, like, are these prototypes over here?
Yeah, those are particular prototypes of the unit, and also those are other prototype devices, which are the same as that little one that you saw. This right here is another prototype, which is what's used. Liquid nitrogen goes through the center of that and fills up so it turns superconductive. And here is unique because we have one of our units here, which we add current through it, and then we also have a coil here, which is used to divert the current out of the superconductive ring using an electromagnet.
Wow. And I see you do a lot of homework.
Well, yeah, what we
lot.
have here is basic. It's not that complicated. It's just basic algebra. But what we do is we calculate how much current we can create in the superconductor. We also calculate how much magnetic field strength we need to divert the current out of the superconductor. And we also calculate how much energy is stored by charge and how much energy is stored by current. So
Now, these looks like some wicked equations.
Well,
they don't look
they're-
like the algebra I took.
Well, they're using algebra to try to understand some concepts. Like up here, there's a couple little equations, which is voltage equals current times resistance. And then when we lower the resistance, we increase the current. The wattage that goes into the home is voltage times current. So no matter if our voltage is small, then we increase our current and our current gets higher. And then our wattage is what we're looking for. We're looking for that high power due to high current.
Now I see a really cool illustration right here. What is that?
Well, that's basically a transformer type device. And what we're trying to do is we're building a lot of current in the system first. And then what we're trying to do is discharge that current into a coil, which will create what you call a step up or step down transformer type device using our apparatus. So these are concepts.
This
Sketches.
is one concept. This is a whole different one right here?
Yeah, this is using a capacitor type apparatus to control the current that flows through the
See, I can
superconductor.
see you put a lot of time, a lot of work into this. This is incredible stuff.
Well, it's basic science and material science and it's fun. Actually, it's fun and it's interesting and it's important. It's important to do this. We do have the need for this type of apparatus. We do have a need. Society has a need for that, and you can attempt to solve the problem, and or you can step back and let the things stay the way they are. And I'm passionate about technology, and I know that this problem can be solved. So I decided to solve it.
So if I wanted to find out more about you, how do I look you up? I mean, do I Google you?
Well, yeah, there's a video of me with the unit that is a couple years old on YouTube. I am laying out more details about my work. I've been a little secretive about it for a while because, I'm using technology that was not really as popular a couple years ago. But now I'm becoming more out there and more open and giving more information about what I'm doing. And hopefully that I can get the support I need so I can make this into a manufacturing product that will help a lot of people. It's what's important. It's a goal, and it's something that is successful. Will do a lot of good for people. So that's kind of what you're seeing.
So I could look online and I could find your video from a couple years ago?
Yeah, I think it was 2010 or 2009, this video, and I was going after a contest, and I decided to kind of get a video going. So my wife posted the video.
So you don't have like a Twitter or a blog?
Well, I have a Facebook connection. I have a website that talks about the generator and talks about some of the science behind it. I'm posting more information on that site. It's kind of hard to keep up the site and also do all the science research. It's just a couple of us that's working on it. So I'm trying to get someone that'll help me keep updating my website and updating my Facebook information.
So who are those working with you?
I have a dear friend of mine named Vern, who actually the machine shop that I'm in is his, and him and me have worked, collaborated together to get this done. And some of the machining that was needed for the materials, he does for me. And so we kind of collaborate together. He's dedicated to the project too, and he sees some of my results, which is really good. I have another person who was named Jonathan, who actually created the website for me, and he actually volunteered that service, which was really nice to help me get the word out. And then I have my lovely wife that supports me 100%, and I have a dear friend named, his nickname is JJ, and he kind of helps me with some of the mechanical work that's being done while I do some of the physics plus mechanical work. So it's just a couple of us, but that's all you need. I mean,
Right. I could see the fruits of your guys' efforts and your labor. So what's the goal of this machine? I mean, I know you make the power. You can. Are you planning to start, selling? Are you going to sell to a big corporation? Are you selling straight to individuals?
Well, what we want to do is we want to perfect the technology, and we want to work with other corporations to be able to get it out in the marketplace. But we also want to keep doing our own research and doing some manufacturing ourselves. And so that's something that is part of our plan, my general plan for the future. It's important to get this type of technology and these units out. There's a couple other people out there that are working along the same lines, but I think that I've perfected a very robust machine and a very efficient machine. So I just need to, get more funding and keep going down the line, and I'm asking for help from people, and I've dedicated a lot of my financial, money and time into this, and it's paying off. I just need to keep going farther. Ain't that right?
Right. How important do you think these generators are to the average person?
I think the average person doesn't have any idea how important this technology is because they're not exposed to this technology. But the reality is that it's very important because what it does, it actually protects you from not having power available for you when you need it constantly. And when the demand of electrical energy gets so high that these type of units will become more as a option. The electrical cars are a major technology which is being more and more looked at and used because the price of gasoline is going up. So these type of units that produce electrical power can also be used at the home to help charge up your electrical vehicles and save you money. The units will be leased to people for a set fee every month, and that set fee can be managed and budgeted.
That's awesome. Oh, I'm glad to have met you, Dennis Braxton and Alexander Lee Braxton.
Hey, Alexander. Thank you for coming.
Awesome. Thank you for giving me the tour.
All right.
Bye.
All right, bye.